All right, now we're going to use delta H naught sub F, and I'm going to show you how to use that to calculate delta H naught for any reaction. So this can be used to find delta H naught, standard enthalpy change, for any reaction. Okay, and there's a simple equation, and it is delta H naught for whatever your reaction you're looking for is equal to the sum of delta H naught sub F of products minus the sum of delta H naught sub F of the reactants. Now, unfortunately, we already learned bond dissociation energy, and this is exactly the opposite equation I gave you. In bond dissociation energy or bond energy, it was reactants minus products. Here, it's products minus reactants. There are reasons for that, but if you want to know, email me or Zoom me next office hours. Okay. So let's use this to find the delta H naught for a reaction. So C6H12O6 solid, that's just glucose, going to 2C2H5OH liquid plus 2CO2 gas. Okay, and this is fermentation. This is the equation that describes fermentation of sugar into alcohol. Now I have your attention. All right, so if we want to know the delta H naught for this reaction up above, is simply the sum of the delta H's of the reactants minus the sum of the delta H's of, I'm sorry, I said that backwards. It's the sum of the delta H's of the products minus the sum of the delta H's of reactants. The delta H naught sub F can just be looked up in the back of the book. You don't need to worry about where you find them on exams they'll be given, unless of course you're asked to find one. So we're going to take products first. We're going to start with the ethanol. So we have two ethanols. I'm going to put this all in big brackets. Two ethanols, and we look up the delta H naught sub F. It's 277.7 kilojoules per mole. Okay, and then we'll go to the CO2. Again, there's two CO2s, so, and this is the sum of, so plus 2, and formation of CO2 is negative 393.5 kilojoules per mole. Oh, and I should write, these are moles, because that'll cancel the units. And then end brackets minus 1 mole, we're doing the glucose now, 1 mole of glucose, and its delta H naught of formation is negative 1273.3 kilojoules per mole. Okay, add that all up, and that is just negative 69.1 kilojoules, because the moles cancel. Okay, pretty straightforward. So let's just do one more example. What is delta H naught for the following reaction? All right, this is going to be the same exact thing, but different reaction. 2C2H2 gas plus 5O2 gas. There's a little bit of a twist here. Plus 4CO2 gas plus 2H2O liquid. Okay, pause your video. Look these all delta H knots of formation up, see if you can calculate it on your own, and then come back and watch the rest of the video. All right, so now that you've done it all on your own, I'm sure, right? We're going to go ahead and work our way through it. First, we're going to start with the CO2. Okay, so 4 times CO2's value is negative 393, same as it was up above, 0.51 kilojoules. And I'm going to get rid of the moles because I'm multiplying by moles. Oh, delta H naught is equal to square brackets. That's just to keep everything tidy. Now move over to the H2O. That is negative, or 2 plus, there we go, plus 2 times negative 285.8 kilojoules minus, and let's do the C2H2, that's acetylene, and we have 2 of those, and that is a standard enthalpy change of 226.7 kilojoules plus 5 times, let's do oxygen. Now I have a question for you. What's the reaction for the formation of oxygen from elements? So if we're forming O2 gas from elements, what elements does it form from at standard state? O2 gas. What's the delta H naught of formation for that? What's the energy change? 0. So this is 0, and that's true for any element, okay? Any element in standard state, the delta H naught of formation is 0, because you can't, if it's forming from elements, there's no energy change. Okay, just calculate that all out, and I get negative 2599.16 kilojoules. Definitely not rounded to the right number of sig figs. Probably just 1 decimal, so negative 2599.1. But at this point, the sig figs are not what's really important. Okay, so hopefully you guys caught all that and you can do those on your own.